Hi, I'm Phil Porras, and this is a demonstration of network security policy enforcement using FortNOX. Our demonstration is run using Mininet, in which an OpenFlow-enabled virtual switch manages traffic between a demo client and server. The upper left console shows an external client host who will open network connections to our internal server, shown in the upper right. In the lower right, the blue console shows our NOX controller, which inserts flow rules into the switch, enabling the client and server to communicate. Let's begin by starting NOX and confirm that it allows the client and server to communicate. With NOX up, we will start a simple echo service on the server and allow our client to bounce a small data stream to and from this service. This small app will send and receive 22 bytes from client to server. Now let's suppose that a security application decides that those 22 bytes carried malicious content and decides to tell NOX to send a block rule to the switch. I'll use dpkittle to dump the switch's flow table and confirm that two rules were inserted with null actions. These tell the switch to drop the client and server flows in both directions. To summarize, the security application makes a policy decision that the client and server shall no longer be allowed to communicate. It sends two block rules to the switch via NOX, which halts all flows between 2 and 4. Let's confirm that our block rules have the desired effect. I'll restart the echo service on the server and attempt to send traffic from the client to this service. This time, my client connection times out. Okay, that should be enough to satisfy us that our network can indeed protect itself through dynamic policy insertion. However, we must also realize that OpenFlow provides many powerful features, including the ability to program the switch to perform inline rewriting of packet content, including IP addresses. An adversary with knowledge or even authorship of a third-party OF application could exploit OpenFlow's rewrite logic to circumvent our blocking rules, even if these block rules are installed with higher priority. Let's suppose host 2 sends a connection request to host 3, which may or may not exist in our topology. The third-party application could react by producing a virtual tunnel using a flow rule that incorporates modify actions. When installed in the switch, these rule actions will change the source IP from host 2 to host 5, and the dest IP from host 3 to host 4. A complementary rule is also inserted for the inverse flow. The transformations enable host 2's flows to reach host 4, as if the flow had originated from host 5. The block rule remains satisfied, as there is no request from host 2 to reach host 4. However, our virtual flow through host 3 and 5 enable 2 and 4 to continue their communications. I'll quickly illustrate this scenario by installing flow rules with the modify actions that transform the client and server packets as I just described. I can view the switch's flow rules again to confirm that my modify rules have been inserted and my block rules are still present. I'll run my client and server test again, but this time I will direct the client to connect to host 3, triggering my modify rules to tunnel host 2 packets through host 5 and on to host 4. Host 2 and 4 can now communicate, despite my current policy, which explicitly prohibits this. Let's try this scenario again, this time using FortNOX. I'm going to reinstall our block rule to prevent host 2 from reaching host 4. I'll restart the server's echo service and confirm that the client cannot reach it. Now, let's reinstall our evasion rules to see how FortNOX deals with this policy conflict. This time, FortNOX identified that my evasion rules represented a conflict with the block rule. As a result, FortNOX rejected the evasion rules. As I did last time, I'll target my flow to host 3 in the hope that my bypass rules will rewrite the header to funnel my session through host 5 and on to host 4. This time, host 2's flow to host 3 is not translated by the flow evasion logic and instead produces the expected failed connection error. To learn more about our FortNOX patch to Nox, visit www.openflowsec.org.